For centuries, we called it the morning star, a beacon of beauty in our night sky. But behind that veil of golden clouds hides a reality that defies sanity. Imagine a place where lead flows like water, and the air is so dense that walking through it would be like moving along the ocean floor. An environment where the heat would make California's Death Valley seem like a spring oasis, and where the pressure would crush a submarine like a soda can. Today, we delve into the greatest feat of Soviet engineering. We are going to see, through the eyes of those who were there, what the Venera probes discovered before being devoured by the furnace. If you are passionate about the history of space exploration, we invite you to subscribe. Your support allows us to continue narrating these chronicles of knowledge. In the heart of the 1970s, while NASA in Houston, Texas, celebrated the success of the Apollo missions, a different challenge was brewing in the Soviet Union. They were not seeking the moon, but the most hostile planet in the solar system. They knew Venus was a world of extremes. If we think of the arid plains of the Australian outback or the stifling heat of a summer in Seville, we would not even be close to imagining the magnitude of the climatic disaster that is Venus. Sending a probe to Venus is not a mission of exploration. It is a suicide mission against the clock. Engineers knew their machines had their minutes numbered from the moment they touched the ground. To withstand 460 degrees Celsius, a temperature higher than an industrial oven, they designed shielding that is not even used on North Sea oil rigs in the United Kingdom. The atmospheric pressure there is 90 times higher than on Earth. It is the same pressure you would find nearly a kilometer beneath the waters of the Canary Islands. The Venera probes were, in essence, armored vaults. The cooling system used blocks of ice and gas circulation to keep the electronics alive just a bit longer. All to answer a single question: what does the surface of Earth's evil twin look like? To achieve this feat, scientists at the Lavochkin Design Bureau did not stop at building a titanium safe. Before the lander detached from the orbiter to descend into the abyss, it underwent extreme pre-cooling, lowering its internal temperature to 10 degrees below zero. It was a desperate attempt to gain every possible second against the thermonuclear heat waiting below. But the true ingenuity lay in its method of landing. Unlike missions to Mars, the air on Venus is so dense, it behaves almost like a fluid. After slowing the initial fall, Venera 13 shed its parachutes at an altitude of 50 kilometers. From there, it simply swam downward. An aerodynamic stabilizer ring at the top acted as a brake, allowing the probe to descend steadily, like a coin falling to the bottom of a deep fountain. This design was a necessity. On Venus, conventional parachute cords would have corroded or become entangled in the hurricane-force winds of the upper atmosphere. Even the serrated teeth at the base of the lander served a critical function. They were not for the landing itself, but to prevent the probe from oscillating during the descent, and to provide scale references in the photographs. Every piece of this Soviet ingenuity was designed for a suicide mission with only one reward: data. Data that would allow us to understand why the fate of Venus was so different from the coasts of Florida or the fields of Castile. March 1st, 1982. After a months-long journey through the vacuum, Venera 13 pierces the dense atmosphere of Venus. It does not fall like an ordinary object. At that pressure, the air is so viscous the probe seems to descend through an ocean of gas. Upon touching down, the systems record a sharp impact. For 127 minutes, double what was predicted, the probe became our only outpost in hell. What it saw was an alien landscape that challenges our perception of color. Under a perpetually cloudy sky of sulfuric acid, blue does not exist. The atmosphere is so thick it filters all light frequencies, allowing only ochre, reddish, and orange tones to pass. It is a diffuse, oppressive clarity, similar to the dying light that precedes a dust storm in the plains of Texas, but with an atmosphere composed of poison and constant heat. Look at the rocks. They are flat, sharp, and basaltic in nature. If we were to walk there, assuming our bodies were not instantly crushed, the terrain would remind us of the volcanic fields of the Canary Islands in Spain. But here, the air has such density that if you tried to move an arm, you would feel the same resistance as swimming underwater. This world, ironically, looks much like what geologists believe Earth was in its early stages, before life transformed it. To see Venus is to look through a window into the most violent past of our own home, a version of Earth that went wrong and became an eternal furnace. Why have we not returned with such intensity? After the Venera missions and NASA's Magellan mission, Venus faded into the background, eclipsed by the reddish glow of Mars. However, Venus is the mirror we do not want to look into. While Mars is a frozen desert that lost its atmosphere, Venus is the result of a runaway greenhouse effect, a thermal engine with no brakes. Imagine for a moment the humid, sticky heat of a midday in Miami, Florida, and multiply it by 1,000. On Venus, the carbon dioxide is so dense it traps solar radiation implacably. What the Venera saw was a planetary graveyard, a reminder that the difference between a paradise, like the eternal greenery of the Asturias valleys in northern Spain, and a hell is barely a thin layer of atmospheric gases. Despite the lack of landing missions in recent decades, the data collected by those Russian missions remains, to this day, the fundamental pillar of Venusian geology. Every rock analyzed by Venera 13 tells a story of colossal volcanoes and tectonic activity we are still trying to comprehend. But the silence is about to break. NASA and the European Space Agency are already preparing their return with missions like DAVINCI and VERITAS. These new spacecraft will look for evidence of what many scientists suspect: that Venus once had oceans of liquid water, perhaps as vast as those bathing the coasts of California. Was Venus the first Earth? And are we simply the next chapter? The answer lies not in the distant stars, but in that bright point we see at sunset. We return to Venus because to understand our future, we must first understand how our twin brother died. Those grainy photographs sent across millions of kilometers of vacuum are the testimony of our audacity. We went to hell, took a photo, and came back to tell the story. If this journey through time and space has fascinated you, we would appreciate a like and for you to share your opinion in the comments. Thank you for joining us once again in this search for answers.